Right. So let's see here. Right. So let's go through the homework on alcohols that I gave you yesterday. Right. So we learned that alcohols are compounds, organic compounds that have the hydroxyl functional group. Right. So the hydroxyl functional group, that is the hydroxyl functional group. Notice how I spell it, hydroxyl and not hydroxide, all right? Hydroxyl is OH covalently bonded to the hydrocarbon chain, whereas hydroxide would be OH minus, which would be in a ionic bond with whatever it's bonded to, which would invariably be a positive metal ion or a positive ion. Okay. So let's take a look at the longest chain. The longest chain has got 3 carbons in it. Meth, eth, prop. Okay, so this is prop. Okay, it is, we can say, anol. Propanol, and I know Josh likes to use this particular convention, which is not wrong. He looks at which carbon the hydroxyl group is attached to, and it doesn't matter whether we number from left to right or right to left, because it's a symmetrical molecule. The OH is going to be on carbon number 2, and say you like 2-propanol. However, there is a different way of doing it, which is equally correct, and that is to say propan 2-ol. Propan 2-ol. Both of them are acceptable. Okay. Yes, Josh?
You can't say propanol 2.
No, you can't. And the reason is that's not the rule. Okay. IUPAC has got a very clear set of rules about naming. Yes, Dick.
Up till matric, will both methods be valid?
They are both valid. Yeah, they're both valid. All right. Now, let's look at this one. All right. Now, here, we want you to use the convention that I prefer to use. Okay. So looking here, the longest chain has got 3 carbons, meth, eth, prop. So this is going to be propan. Now, if we look here, 1, 2, 3, 1, 2, 3, doesn't matter which way we number it. This is going to be 1, 2, 3. 1, 2, 3. Try all. Okay. Now, Josh would like to say 1, 2, 3. Propane triol. Is that acceptable? I'm not sure. So I would rather you use this, which is definitely acceptable. I would think that 1, 2, 3 propane triol would be acceptable, but I don't know. I don't mark NSC chemistry, so I am going to go with the safer option. Are we okay with that? Okay. Cool. Right, let's move on. Any questions on that? Right, next. If we look at this alcohol molecule, the longest chain got 1, 2, 3, 4, 5. So this is going to be pentanol. Pentanol. Right, there's one hydroxyl group, so this is going to be pentanol. Sorry, let me just stick with my convention. Pentanol. Right, now, this hydroxyl group here, could have been on carbon 2, carbon 3, but it's on carbon 1. So we're going to number from left to right, because pentane 1-ol, the number that we use as the descriptor is lower than if we numbered from left to right. 1, 2, 3, 4, 5, pentane 5-ol. So we don't use that numbering. We use this numbering. So you could say this is 1 pentanol, or you can say this is pentan 1-ol. Are we okay with that? Okay, excellent. All right, let's look at the next one. If we look at the next one, we have the carbon backbone, and the longest chain must include the OH. So this means this becomes a methyl group. Right, so there is the OH. So the longest chain is going to be meth-prop bute. So this is going to be butanol. Okay, and we're going to number 1, 2, 3, 4 from right to left, because that means the OH is going to be on carbon number 1 as opposed to carbon number 4 if we numbered from left to right. We're numbering from right to left. So this is going to be meth-prop bute. This is going to be bute and 1-ol. Right, now the methyl group is on carbon number 2. So this is going to be 2-methyl butane 1-ol.
So won't you put a dash into the methyl?
Yes, yes. Do not put a dash between methyl and butane 1-ol. You can leave a space. I think leaving a space, you shouldn't get penalized. Yes, Noah?
Can you put 2-methane, 1-butanol?
Not methane.
I mean,
Methyl. This is not methane. Methane's CH4. This is a branch. So it doesn't have a fourth hydrogen. It's connected to a carbon chain. So it's methyl.
But if I was to put methyl, would it be 2-methyl, 1-butanol? That would.
Oh, you mean 2-methyl-1-butane? Oh, I think it's fine. Okay, on grade 10 level where we're doing this, we would accept that. Okay, would I prefer you to do it this way? I would prefer you to do this way, but I think that way is acceptable.
You need the one between the M and O.
Yes, because there's other options, other carbons where the OH could have been. You see, the OH could have been on 2, and it would have been butane 2-ol.
So then with pentanol.
Same here, because you have another option. If you put the OH on 2 or 3, then you get positional isomers. The only time you leave it out is if it doesn't make a difference where you put the OH. So, for instance, in methanol and ethanol, where your OH doesn't require a number. But as soon as you go to 3 carbons, then you have more options where you could put the OH, and then you get positional isomers. Okay, good question. Very good question. You need to be explicit in this case as to where the OH could be. What a question. If we had taken the OH to that side, so we know that here this would be butane 2-ol. We took it to that side, what would it be? Butane 2-ol. We would then be forced to number from left to right. But then the methyl would be 3-methyl. Alan, is that what you wanted to do? Okay. Cool. All right, so let's move on. Let's now go to this one. Now we have options. We have options about the chain length. Can you see going from left to right, we get a chain that's got 5 carbons that includes the OH. Or I could go from top to bottom and I would have 4 carbons. Which one is the longest chain? What did you want to ask?
I was going to ask, does it matter obviously the methyl and the pentanol? together, do you have to put the capital?
No, you don't need to. No, you don't have to worry about capitals. Don't stress about it. Right, so the longest chain here is going to be that one. 1, 2, 3, 4, 5. The OH is included, connected to the chain. If we look here, if we went this way, if we did this, it would be 1, 2, 3, 4. If we did this, it would be 1, 2, 3, 4. So we're not going to use those as the longest chain. So this is meth-eth-prop-but pentanol. So this is pentanol. I'm going to take it across here. Right, so this is going to be tan. If we count 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5, doesn't matter. This is going to be carbon 3. Right, so this is going to be pentan 3-ol because of the OH. But there's a methyl group. And the methyl group is going to be 3-methyl. So this is going to be 3-methyl pentan 3-ol. Yes.
So, if you had to put any of the other,
Can you just speak a bit louder, please?
if you had to put any of the other halogens before the pentanol, would that also make sure that there's most base or
Whether you have a halogen in front of this or you have an alkyl, you have to connect it to the branch. But you've got to then do them in alphabetical order.
Yeah, no, I was just asking about the dash.
Okay, dashes go when you're using numbers. So whenever you use a number, you must use a hyphen. Okay, so can you see here, you're using a number, you use a hyphen. Using a number, you're using 2 hyphens. All right, good question. That's a good question. We're learning a language. We're learning the IUPAC language. All right. Now, if we look at this one, right, this one here, the longest chain is easy. So this is going to be meth-eth-prop-but-pent. So there's definitely, it's pent. Sorry, I'm struggling here. So this is definitely going to be pent. So, sorry, guys. Yes.
I wanted to ask, also for this one, I don't know if it was, but there's also 3, right? For like, there's a missing.
Oh, I see what you mean. There's a mistake in the diagram. Definitely. You don't have to feel confused. You are right. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3. There's a hydrogen bond. There's a bond with a hydrogen missing. Thank you, Dito.
And another one.
And yeah, 1, 2, 3, 4. All right. And it's good to do the circle test. Well done.
What if then maybe it was supposed to be a double bond?
No, the double bonds we would have explicitly shown. Okay. So there's no double bond there. It's 1, 2, 3. This fourth one is a single bond that's missing. 1, 2, 3, 4. Thank you, Dito. Now, it's always good to do the circle test. Okay. So now we look and we go, all right. So we have pent, and it's going to be a null. But now note that we have got 2 hydroxyl groups. 2 hydroxyl groups. Okay. So if we look at this, the lowest numbers to describe the position will be when we number from left to right. 1, 2, 3, 4, 5. So this would then be carbon 1, carbon 2, carbon 3, carbon 4, carbon 5, and it would be 1, 2 diol. Are we okay with that? Because it's 2 hydroxyl groups. So this is going to be penta. All right, we're going to have 1, 2 di, and it's going to be penta 1, okay, pentan.
1, 2 diol.
Okay, now I've got to be careful here. Okay, so this is a diol. So normally it would be pentanol. So it's going to be pentan 1, 2 diol. Okay, all right? Pentan, because this is anol is the suffix for alcohol. So it's going to be pentan 1,2 diol. Right, you have to have your wits about you. Yes, Josh.
So with the OH, will that always take priority? Like,
Yes. Yes. Very important. When it comes to double and triple bonds, they take first priority when coming to numbering. Then you've got, and there is actually a clearly defined set of order of priority, okay, which we don't have to use that much on school level because our compounds aren't that complex. But when you're dealing with an alcohol, it's then going to take precedence. Okay. The double and the triple bonds will be first priority, and then the hydroxyl group, and you're going to see the carboxyl group is always in our syllabus, it's going to be at the end. Well, it's always going to be at the end. But anyway, with the compounds we're dealing with. All right, so let's take a look here. So now we've got the numbering. Now we must see there's a bromine there. Right, there's a bromine there. So that bromine's going to be on carbon number 5. So this is going to be 5 bromo pentan 1,2 diol. Yes, Tito.
I wanted to ask, so you said these two OH are hydroxyl. I thought they're hydroxide.
No. Hydroxide is, if we deal with acids and bases, right, you often come across sodium hydroxide. Now, why is this hydroxide and not hydroxyl? Well, this is a metal ion +1, and this is OH -1. This is a hydroxide because this is an ionic bond. Whereas this is not an ionic bond. This is a covalent bond. Okay, very important. Okay.
so if instead of those two H's there was a double bond there, how would you name that?
Where are you talking about now? Yeah.
No, wait, you know you drew your hydrogens?
Okay, then you'd have to take out 2 hydrogens here.
If there was a double bond.
Okay. Then your first port of call would be that now you are now dealing with an alkenol. We're not going to do that in our syllabus. Okay. All right. You can. A double bond takes preference then with the numbering. Not in our syllabus. All right.
On that note, do we not cover any mixing of suffixes like the alls and the ands, the alkenes and the...
We don't mix too much. We do a little bit of mixing, but we don't mix, for instance, double bonds and triple bonds. You can have alkenes and alkynes, you can have it in the same compound. You can have all sorts of stuff. It gets very complex. If I can tell you a humorous story, years ago, I taught a boy whose mother was an organic chemist, right? We used to enjoy parent evenings because she was exceptionally beautiful, all right? She was also very nice. And her son, Sean, was very, very clever. And whenever she used to come for parent evenings, I really used to enjoy it, okay? And then the one day I asked her, I said, tell me, how do you name the very complex organic compounds that you have to deal with in industry? She said, I don't. We don't have to name them. I said, what do you mean? She says, we're not going to spend days trying to name these things. We've got computer programs that do it, programmed with IUPAC. And it basically just goes along the compound. It goes, pops it out. Okay. It can get exceptionally complex. And as they add to the library of organic compounds, so they need to update IUPAC. Okay. So it's a complex system. You can get very, very complex very, very quickly. Okay. All right. I am not an organic chemist. I don't lay claim to being one. I can tell you the other two organic chemists in our department, we've often had meetings on nomenclature. Like, how do you actually name this thing when you start to get to very tricky, even on NSC grade 12 level. Okay. We will hopefully get to some exam questions, and then you'll see the level at which we'll ask. Okay. Now, before we move on to carboxylic acids, I want to talk about primary, secondary, and tertiary alcohols. Right, so let's go back here, and I want to see whether you can see what the pattern is. I am going to tell you that this is a secondary alcohol. Just bear with me. This is a secondary alcohol, which I'm going to use the abbreviation 2 degrees. That is a secondary alcohol. All right. This one's got more than one hydroxyl group, so we're not going to look at that. This one is a primary alcohol. What we call a 1 degree. And this one here is a tertiary alcohol. This is what we would say is a 3 degree. What is the rule? Depending on the carbon it's bonded to,
then it'll likely be primary, tertiary.
okay, so why is this called a primary alcohol? And there's only one alkyl group that is bonded to that carbon. Agreed, Mbali? Well done. Why is this called a tertiary alcohol? Well, OH is bonded to carbon. Yes. We don't work with tertiary, primary, and secondary. Only with single hydroxyl groups. Good question. Can you see that this carbon that the hydroxyl group is attached to has got how many alkyl groups attached to it? This is very important for chemical reactions, ladies and gentlemen, because when we do chemical reactions, the reaction conditions vary based on whether it's a primary, secondary, or tertiary alcohol. So it's important to, and we ask this explicitly, what is this, a primary, secondary, or tertiary alcohol? All right, Kavar, this OH is connected to the carbon. How many alkyl branches are attached to this carbon? Nope. It's okay to be wrong. Nope. 1, 2, 3. That's why it's tertiary. Can you see this carbon? There is 1 alkyl branch, 2, 3. That's a tertiary alcohol. Because the carbon that the OH is attached to has got 3 branches attached to it.
So it's not because it's on the third.
No, it's not because it's on carbon 3. It's not on carbon 3. If I had another 2 carbons here, this would still be a tertiary alcohol. The tertiary is because the OH is connected to a carbon, and that carbon has got 3 branches attached to it.
You can only get primary, secondary, tertiary.
Yes. Yes. If we now go here, can you see that this OH is connected to a carbon, and that carbon has got 1, 2 alkyl branches attached to it? Can you see it's got a methyl and a methyl? Whereas this one has got a methyl, an ethyl, and an ethyl. Got 3 alkyl branches. All right, so that is important to remember. The next thing I want to do with you is, and I just want to see how much time we have left. I can do it in that amount of time. All right, I've got still 15 minutes. I've got 15 minutes. So we can do this. The next is carboxylic acids. So an acid is a substance that releases hydronium ions in water. You're doing this in grade 10, so you actually haven't done what we refer to as the Arrhenius definition of an acid yet. All right, we will do that next year. We're going to do that in grade 11. But just for this, at this point, It's good to know that an acid is a substance that releases hydrogen ions in solution, producing hydronium ions. Right, now, carboxylic acids are a homologous series containing the carboxyl group. Right, now the carboxyl group, I'm just going to quickly produce it here. Let's see if I can do that. Yeah. Didn't have my milli pop this morning. Okay, so your carboxyl group is going to look like this. All right, carboxyl group is going to look like this. You've got a C. You have an OH, which looks like an alcohol, but it's got a double bond. It's got a double bond with the oxygen there. All right, so let's explicitly look at the carboxyl group. Okay, so the carboxyl group, this is the functional group. The carboxyl functional group looks like this. You have a carbon, and this carbon has got 4 valence electrons. All right, 2 of which are bonded to an oxygen. Remember, oxygens are in group 6, so they've got 6 valence electrons. All right, a double bond forms between 2 of the electrons that are in the sp3 orbitals of carbon, right? And these lone pairs are not involved with the bonding. Then another electron in an sp3 orbital, valence electron, is bonded to another oxygen, right, with a single bond. That oxygen has got 2 valence electrons, not 2 valence electrons, 2 lone pairs, okay? These are lone pairs. These are lone pairs. These are bonding pairs. It's a bonding pair. And oxygen has got 6 valence electrons. 1, 2, 3, 4, 5, 6. And this electron is bonded to hydrogen. And the carbon has 1 valence electron left open. 1 orbital left open. Now, this can then bond with other carbons. In the case of methanoic acid, this is bonded to a hydrogen. But you can very, very quickly add this to the carbon chain, like I'm doing here, right? And we can then get carboxylic acids that look like this. So if we look at this one, how many carbons does this one have? 1, 2, 3, 4. So this would be meth, eth, prop, butanoic acid. Right. So we are not going to use Lewis diagrams. We're going to do the following. We're going to say C double bond O, O, H. That is the carboxyl functional group.
So for this, I assume you can also have it branch off in, say, the middle of
Yes. So if you take something like polylactic acid, have you heard of PLA? PLA is, if you look at what they call the monomer unit, the actual monomer is lactic acid. I'm not a biologist. It's in actual fact a carboxylic acid and an alcohol. All right, and then it actually can form into a polymer. There's all sorts of combos that you can get. We are going to work in our syllabus with carboxylic acids where the carbon is going to be on 1, on carbon 1. All right. So let's take a look at this. This is the functional group. What is the homologous series? We ask these questions. Carboxylic acids. These are the homologous series. The family is called the carboxylic acids, but the functional group is called the carboxyl functional group. But we have a slang that we use. We call this the Q group. The Q group. Sophia, are you with me? Okay. Q group. Can you give me an example of an acid, carboxylic acid, that we use on a regular basis? Vinegar. Vinegar is ethanoic acid. Okay. So if we go here, we go back, all right? So if we look at methanoic acid, we've got one carbon, 1, 2, 3, 4. Two of the bonds are with oxygen. One of the bonds is with the OH. That's methanoic acid. Okay. Ethanoic acid, also known as acetic acid, is also vinegar. So that's what vinegar looks like. I have a question. Okay, but you're under 18, so you shouldn't know this. If you drink wine, what alcohol are you drinking? Ethanol. Ethanol. If you leave wine open for a very, very long time and you taste it, what do you find? It's acidic because the ethanol gets oxidized and becomes ethanoic acid. Tastes like vinegar. It's because it gets oxidized. Yes.
All like alcohols like that we drink, or all of that ethanol.
I would not suggest you drink anything else other than ethanol when you're over the age of 18. All right. When I was a young boy, on a Friday afternoon, my father would go to the local liquor store and he would go and buy his 6-pack of Castle lagers. My father, not Castle, Lion, he never drank Castle, Lion lagers. And my father was always he was never overdrank or anything. He would have his 6 Lion lagers over the weekend, watching cricket and rugby. It was fine. I would go with him. And outside would be these hobos, as we call them. Okay, we would say homeless people today. And the sad thing was that because they couldn't afford the alcohol, they drank methylated spirits. Now, the methylated spirits was cheap. You could buy it at the hardware store. And they would take white bread and they would use the white bread as a filter to get out that dark blue dye. And they would pour it through and then drink the alcohol. The problem is that alcohol was methanol. And your body, when it metabolizes the methanol, produces something that makes you blind. They had white eyes. Some of them, you could see the glaze on their eyes. They were going blind. I never forget it as a little boy. And I asked my dad, what is going on with these people? He said to me, that's what was going on. Like, he didn't give me the chemical explanation. Now I know, but he said to me, they're drinking methanol. Right. Even pure ethanol will kill you. Okay, so those of you who like to drink lots of straw rum, you shouldn't be because you're under 18, but straw rum, it's got a high percentage alcohol in it. All right, so on to a more upbuilding subject. I would like you to please complete practice 9. All right, please complete practice 9. Have any of you ever been bitten by a red ant? You got injected with methanoic acid, also known as formic acid. All right, and this is really interesting. You know that all of us have got a unique sweat signature. All right, so bloodhounds, apparently bloodhounds, their smell is tens of thousands of times better than human beings. Police dogs, you know, it's actually, how many of you have been in an airport, an international airport, even at Cape Town, and they walk past the dog? walk past with the dog. And then you look and you know that dog is looking for drugs. It can smell the drugs. All right. Now, if a child gets lost or someone gets lost or kidnapped, they don't know where they are, they take clothing from that person with the person's sweat on it. And then the dog smells it and then tracks the unique signature of the composition of carboxylic acids in the sweat. Oh, yes. Your sweat signature, or unique mixture of carboxylic acids that your body produces. And I think that is super cool. All right. Okay, so ladies and gentlemen, can you please do, in this homologous series, can you please complete this table? And I leave that over for the next lesson. This is your homework. Yes, Dylan. Declan. Yes, Declan.
For these, it doesn't specify the